Have you ever wondered why your connection sometimes feels sluggish, or where data might be getting stuck on its journey across the internet? It can be incredibly frustrating when a website loads slowly or an online application lags, making you wish you could see exactly what is happening behind the scenes. Traceroute reveals network latency by measuring the round-trip time it takes for small data packets to travel from your computer to each successive network device, or hop, on the way to a destination. Essentially, it maps out the entire route and times each leg of the journey, allowing you to pinpoint where delays are occurring. The core mechanism behind Traceroute relies on the Internet Protocol and the Internet Control Message Protocol, or ICMP, specifically using a field called Time to Live, or TTL. When your computer sends out a Traceroute packet, it starts with a TTL value of 1. This packet reaches the very first router, which then decrements the TTL to 0. Upon reaching 0, the router is programmed to send an ICMP, time-exceeded message back to the source. Traceroute records the time taken for this round trip. It then repeats this process, incrementing the TTL value by 1 for each subsequent set of packets. For instance, the next set of packets will have a TTL of 2, allowing them to reach the second router before expiring and triggering another ICMP response. This continues until the packets reach their final destination or a maximum number of hops is exceeded. By timing the return of these ICMP messages, Traceroute effectively measures the latency for each individual hop on the network path. To utilize this information, you can typically run a Traceroute command from your operating system's command prompt or terminal. Once the results are displayed, you will see a list of numbered hops, each followed by 3 round-trip time measurements, usually in milliseconds. Consistently high numbers for a particular hop or a series of hops indicate a point of congestion or high latency. Furthermore, if you see asterisks instead of time measurements, it often signifies packet loss, meaning some packets did not make it to that hop or the response was not received within the timeout period, which can also severely impact performance. Observing the pattern of these values helps you understand if the delay is local, somewhere in the middle of the internet, or closer to the destination server. What makes Traceroute particularly powerful is its ability to not only show you the latency at each hop, but also to identify the network devices, often by their IP address or hostname, that are introducing those delays. This capability is invaluable for diagnosing complex network issues because it distinguishes between general internet slowness and a specific bottleneck. For example, if the first few hops show low latency, and then it suddenly spikes at a particular internet service provider's router, you have isolated the problem. It is important to remember that these are round-trip times, encompassing both directions of travel, and they representing the time it takes for the ICMP message to be processed and returned by each router, not necessarily the exact one-way data flow time. Nevertheless, this diagnostic tool provides a crucial snapshot into the real-time health of a network path. Understanding how to interpret Traceroute results empowers you to effectively diagnose network performance issues, communicate more precisely with network administrators or internet service providers, and gain a clearer picture of data flow across the vast and intricate infrastructure of the internet. It transforms a vague feeling of slowness into concrete, actionable insights about where and why delays are occurring.
If you love understanding how the web works, like, subscribe, and stay connected with us.